All right, welcome back. This is CYSAT 2021. Still in Davos, broadcasting live. Day 2 of the event. We had a lot of interesting presentations. This afternoon included talking about constellations, IoT, and this is exactly the focus of this panel discussion that I will be leading. I have the pleasure to be with 4 panelists. I'll introduce first Alexandre Tisserand. Alexandre is the CEO of Kineis, a French company providing satellite communications for IoT devices. We also have Mark Manulis. Mark was with us already this afternoon. If you followed the stream earlier on, he's a security researcher at the University of Surrey. We'll have also Damian Vizár from the CSEM in Switzerland. Damian is a security expert, also working on IoT and satellite applications. And last but not least, we have Nuno, or Nuno, I don't know how to pronounce it, Pires. Nuno is working at Geosatis, a Swiss company providing electronic monitoring of prisoners. He's the head of innovation. Welcome everybody. I'm glad to have you. Thank you again for accepting my invitation to be part of this panel discussion. We had already quite a few keynotes introducing the general need for security, talking about the consequences of satellite hacking in terms of collisions, the risks of service interruption, DDoS attacks, ransomware, also the risk of leaking, of breaches of sensitive data that need to be secured. So we covered already a lot of grounds. We also talked a bit the potential solutions. Mark, I think your presentation was very spot on about the importance of the implementation, the questions about the keys, the cryptographic algorithms on ground, on board, and so on. So this kind of the general landscape that we'll be covering, and also focusing on the lessons that we can learn from these terrestrial applications. I always say that new space, small sats operation remind me a bit of IoT 5 or 10 years ago, in the sense that people try to make it work first and then think about security. We'll see if this is the case. And I'll start with you, Alexandre, CEO of Kineis, as I said. Your company will be launching a constellation of small sats. I would be happy to have your general perspective about security as the CEO of the company. Is it a big deal for you? How do you take it? How do your clients take it? What do you do? What is your general feeling about security overall?
Okay, thank you for the invitation. So yes, Kineis, as a reminder, like you say, is a telecommunication operator dedicated to IoT. So we are a satellite operator, global connectivity provider. Like actually any telecommunication operator, we are really interested in security in our system and the security we can provide to the data of our clients. And maybe, fortunately, we have already 8 satellites already flying with already operational service with several tens of thousands of devices connected to it, and so we have a very strong commitment on security. Like well, telecommunication, it's like postal services. Your customer is waiting for a full secure communication system. Well, actually, it depends on the type of client. For example, scientists, when they are following like birds or turtles or this kind of animal, they are very interested in integrity, but for example, confidentiality is not really a key for them. But for the clients, like institutional ones, you cannot avoid the subject of full security. So definitely it's very important, and at every stage. You said you've talked about the security of taking control of satellites that may lead to collision, for example. But there is many aspects of it. There is the satellite, the fact that you can control it, and also we are talking about the data itself. So you have to focus on the confidentiality, the integrity of the data, and the reliability of the service as well, because your client are waiting for a certain SLA, certain level of service. You have to care also about jamming and interferences, for example, to avoid that your system is going down by denial of service, for example. And so there is several components, the satellite, there is obviously the device itself. Security in IoT is a big deal. And so it can be either satellite or terrestrial. We still have to focus on how you deal security with the object itself to avoid breaches. And there are two other components actually. The first one is the final data center that we have, where we gather the data and deliver to the client. It's more, I would say, a traditional data center and the communication security. And also one important component, which is the ground station network, because the satellite gather data from the of a connected object, but then gives the data back with telemetry to the ground station. So we have a network of ground station around the globe, and obviously these are important assets. First, you don't want them to be compromised, and secondly, you don't want also people to be able with their own station, ground station, to be able to get the telemetry and decode the data themselves without going through our system. I don't know if you have read the news for the last weekend. I read that some people could get the SpaceX second floor rocket telemetry and could decode it, and so they could get a video stream of the camera that was on the rocket. So this is an interesting case of security there. So there is many aspects on the whole system, and just not only the satellites. And it's very important for us to take care of all these components in terms of security.
Yeah, yeah. Just for the participants to understand a bit your plans, can you remind us how many satellites you'll be launching?
Yes,
what is roughly the size?
Okay, so we are talking. So today we have 8 satellites flying. They are LEO satellites at 600 to 800 kilometers with polar orbits. And so we are planning to launch, relaunch, because we are already developing them, 25 nanosatellites. We are talking about 60 new, so it's between 25 and 30 kilograms, including the ring for the rockets, and they are put on 5 planes, polar orbit at 650 kilometers, 5 planes of 5 satellites that are equally distributed around the globe. These are heliosynchronous orbits. So they will be launched in the first semester of 2023 through 5 launches. They have propulsion on board, but not enough to switch from one plant to the other, so we have to do 5 launches.
Okay, thank you for the clarification. Let me go to you, Nuno, from Geosatis. So you're not launching any satellites. However, you are deploying a fleet of connected objects, little bracelets that prisoners wear instead of going to jail. This is one of the most sensitive applications of connected objects of IoT. Can you introduce us a bit to the business of Geosatis and, generally speaking, the security requirements of that particular application?
Yes, thank you, Mathieu, for the introduction, also for the invitation in the name of Geosatis. So we're in the business of making the most reliable and secure solution for the global offender monitoring systems. And we propose a system service that's completely designed by ourselves. Comprises electronic monitoring bracelet, and monitoring applications and several subsidiary hardware. I will just brought you one of the bracelets because it's the cornerstone of our solution. So this goes into an offender ankle, and you just it's comprised of two parts. You can close them. Compared to the competition, we offer a much more robust solution because most of them are based on straps around the ankle, and we believe that's a main security issue because you can just simply cut it down. So the challenges of designing security for such a system are manifold. So we wanted to make sure that we could fabricate the device securely, because cloning, for instance, it's a major threat on our business. Also for the actual usage, the offenders are the ones that spend the most with the device, and they are also the most motivated to attack it. So this typically is for programs 24/7. And we also looked at several aspects. So this required a more holistic approach to security. And when we decided to launch this new version, because this is the new version of our bracelet, we started making a threat analysis to really understand what were the main entry points in our system. And this is very broad. It can go from facility security to rogue, what to do if a rogue employee has access to some sensitive information, to actually, as I already mentioned, how to fabricate these devices securely outside of the company, because we do not we have manufacturing partners. We do not manufacture the device ourselves. And these were the main challenges. When we set up to do this, we had already some experience because this is already the sixth version of our device. So we already had some security in place, very strong security. It was based on symmetric cryptography. But for this device, we decided to go into asymmetric cryptography based on hardware security modules in each component. So, for instance, here I showed you two components. One is the active part, the other is the battery part. There's actually a secure element in each one, and even the communication between the two is secured by strong cryptography. So the challenge here was how do we do it? We do it internally. We search for some partners. We search for some partners to do this. We chose a mixed approach. So we were very happy to have in-house very high-quality security experts, and we just selected some points of collaboration. One of them is exactly CYSAT, to some points of the system. And this was also because we're in a very particular situation. So using off-the-shelf protocols was not an option for us because of the bandwidth that's involved. One such device generates around 1 megabyte of data per day. And we set up designing this ourselves, as I said, in a very comprehensive threat analysis that we did. We started with a collaboration.
Yeah. Can you remind us what is the scale of deployment? How many devices do you have already in the field? How many more do you plan to deploy? Do you have an idea of
we have tens of thousands of devices already deployed worldwide, with a quite steep expected exponential curve. Yes.
Okay.
And I must say that we have another constraint, is that we use the public infrastructure. So the security has to be a cornerstone of the system. For instance, we use the cellular network for communication. We also use open and public GNSS streams. This means Galileo, GLONASS, GPS. And we wanted to make sure that we are completely secure. Also, the internet is backbone, as you might expect. And we wanted to make sure that that we could operate in untrusted channels with very high security.
Yeah, and so just to make sure the audience understands, so the goal is really to draw the parallel between Geosatis deploying tens of thousands of connected bracelets that I suppose are not designed to be to perform any regular maintenance. I think they're supposed to be in the field for quite a long time, and which is kind of a similar situation as maybe Alexandre and Kineis launching satellites, also with no maintenance in space. So really trying to draw the parallel between IoT and new space. Do we see similar challenges? Are there any solutions that exist today, maybe on the ground in terrestrial applications like IoT, that could be also applicable and interesting for space? This is the goal of the panel, to make it clear again. Let's ask Damian. I know you've done some research on terrestrial IoT systems, and you also looked at how this could be implemented for space. Can you tell me a bit more about that?
Yes, thank you. Yeah, first, thank you for the invitation to the panel. So far, very nice conference. So, indeed, right at the start, maybe I should give a disclaimer that my experience is purely terrestrial so far, but I had my suspicions. So we've been in contact with Mathieu before, so I've been thinking how the experience and lessons from the IoT systems could apply to space. And having watched the talks so far, yesterday and today, these parallels were really echoed. So there are certain things which are very similar. If you think about some conceptual features, such as if you think about a satellite system and an IoT system, you do have some sort of more powerful central segment. In the IoT, it would be the cloud. In the satellite system, from what I've seen, it would be the ground segment, which then communicates over some infrastructure, which may be controlled by one or more parties that you may or may not trust. So this is the network and the ground stations with a lot of devices, which once deployed are rather hard to maintain and patch, right? So there are bound to be some security challenges that are very similar. And as far as I can tell, the thing that you have to get right on the first try is your root of trust and a way to maintain a control and upgrade and update your devices once they're out. Because if you think about a satellite or an IoT device, at least from my nicely abstract researcher point of view, it's a device that has some hardware and is running some stack of software, right? Firmware, application code, etc., etc. And it may turn out that something that this device is doing is not as it should be. There's a security vulnerability either in the used communication protocol or in the software itself that can be exploited. And you want to get this right. And for this to work, there are some things you can change, but what you cannot change is your hardware and your elementary trust features. So this is something you absolutely have to get right from the start. You have to think about where do you anchor your trust in the device. As Nuno says, he has two trusted elements for each physical part of the device. And this is exactly what I'm talking about. You need to have a firmware upgrade that works from afar, and you're very, very certain that this nut is broken. And then, the same goes for the management of the most sensitive keys, because this is the backbone of your security and all the encryption, authentication, whatever you want to think about. These keys have to be protected very well.
Thank
and then on the
you.
more
Thank you, Damian.
Thanks.
Let's ask Mark. You covered very extensively all the threat landscape for missions, which is very large. IoT over space is even more complex because you have the ground terminals. It adds another layer in your architecture. What would be your top vulnerabilities, let's say the top three weaknesses or potential threats you would point out to Alexandre, to other new space operators?
Well, I must say we haven't really analyzed security of any satellites, so in that direction, but to point like a concrete vulnerability. But I think with top vulnerabilities are basically those that are known, and as well as those that are unknown. So the known vulnerabilities are available through the CV database. So for example, if you are using some libraries and so on, so I would suggest that you first look there to see whether the components you are using have already known vulnerabilities that you can try and mitigate against. But then, of course, there are zero-day vulnerabilities, so unknown vulnerabilities. And like Damian said, in order to mitigate against that, you can do this only retrospectively. So there needs to be a mechanism for a secure kind of update features deployed. And maybe what the old space has successfully used is some way of introducing redundancy into the system, right? So especially the difference, I think the key difference between IoT devices on Earth and satellites in the space is that eventually you can get hold of the IoT device and you can do manual, let's say, reparations. For example, if you consider like connected cars, right? So certainly in the future, there will be situations where the car manufacturer will recall the cars into the service stations to do some updates. This is something that you can't really do with satellites. So there is a significant difference, I would say, there. So probably having some fallback mechanisms, in particular to protect like crucial communications like authentication and so key management is needed. So that should be somehow part of the design process, I would say.
Okay. What is your reaction, Alexandre? Is security and all these issues, is it something you're obviously addressing from the design phase, or can you tell us a bit where you stand in that process?
Well, yes, I totally agree with some of the remarks that have been done by Damian first and then by Mark, when saying that the satellite is basically, it may be a complex object, but it's still a connected object with, like you said, hardware and a stack of software. And the point is, like some of connected objects, that it's not physically maintainable, so you don't have access to it. And though, of course, you have to sync your trust scheme in the first place, at least for the hardware. And so this needs to be synced and thought a very early stage, and this is what we are doing, obviously. Also, we may have some different approaches between the different communication flux between Earth and space. For example, you don't expect the same level of security for example, the telecommand of the satellite and for the data that is going over the network. I mean, everything is important, but you cannot afford at all to lose control of two satellites. Whereas you can maybe at some point lose one packet of one device at one time. It's not exactly the same level of criticality. Also, Mark talked about redundancy. It's interesting because usually, indeed you don't have access to satellites when it's in flight. Traditional satellites use redundancy in the hardware, so they have the similar electronic cards that are doing the same things, just in case one is burnt or is malfunctioning. Actually, in the new space approach, you don't have really much redundancy. This is part of the, I mean, on the satellite itself, it's part of the philosophy of development. Instead, you may have redundancy in the number of satellites. So I said you cannot afford to lose one satellite. That's true, but still you can more afford to lose one with a constellation of 25 than one with a constellation of 2, 3, even 8. So this is not the same approach of redundancy, and it's interesting to see that new space approach is relying more on statistically the number of satellites than in the redundancy of the cards and electronics in the device, the satellite itself.
Yep. We'll just take one question from the chat. Still, while we are talking about threats and risks, I like this question. Maybe this is for Mark or Damian. Is there any equivalent of side channel attacks in the space satellite context? Can you imagine side channel attacks maybe on the satellite under development? Maybe Mark, what do you think of that?
Well, I think, side channel attacks typically use some external information which can be observed. And so in case of satellites, so the RF communication, the RF signals might introduce some leakage. And also in my talk, I mentioned about like trying to obfuscate and to hide the purpose of the mission by powering up, for example, the antennas and so on. You leak information about what you are doing. And so adding some additional mechanisms there, so some randomization, some noise, this is what probably would be the right approach to do. And of course, the system on chips, they are susceptible to side channel attacks. So whether you can have a side channel attack mounted from a neighbor satellite, which belongs to some adversary, that's still to be seen. But I mean, if it's a wireless communication, then it can possibly be intercepted and observed.
Damian, do you have any comment on these side channel attacks?
Yeah. Actually, it's one of the things that crossed my mind when preparing for the panel, and I agree with Mark. You cannot just dismiss these because satellites float in the space and you feel they're isolated. So there is one side channel which you can definitely abuse, and that's timing. As Mark says, the RF communication can be observed by everyone. And all the timing attacks that apply to any other communication and cryptography on the ground apply to the same cryptography used in a satellite. So that's definitely something that should be taken into account. And, you know, like constant time crypto implementations would be bare minimum to think about. And then if I put on my aluminum foil hat and try to be a bit paranoid, another class of powerful side channel attacks is power analysis. And of course, you cannot really do this because the satellite floats in the space and you can't just go there and attach a probe to measure its power. But when talking about the satellite to satellite links, we have satellites which have a laser which can be pointed quite precisely at a particular place. And is it so far-fetched to have precise temperature measurements which are focused on a particular place in the satellite, which could allow us to deduce the power usage or activity there? I actually don't have sufficient background to know whether this is precise enough to have any useful information. But if we think about military satellites at state level intelligence, you know, maybe this is not so far-fetched sometime in the future.
I really enjoy always listening to these ideas of security experts and researchers, and also some of my colleagues coming up with these scenarios like, what about if a hacker does this or does that? And to some extent, sometimes it sounds a bit like science fiction, but sometimes it is part of the threat model. So coming back to that threat model, we heard a lot during these 2 days, this mantra about know your enemy. Sometimes people know their system very well, like we can control, everybody knows how the architecture of data are flowing around and so on and so on. But the enemy is more difficult to grasp, and this is based on the enemy that all the security mechanisms and protection layers will be built. Let's ask Nuno if Geosatis knows its potential enemies.
Yes, as I said in my first intervention, so we started exactly by that while designing the latest version of our bracelet and the whole system. So we did a threat analysis based on likelihood and also on impact. And by there, we drive to what extent we were willing to go to secure our system. We just point that firmware update is really a critical point. So that's what we also have separate encryption keys to ensure exactly that, different from the communication ones. And I think going back to the first point, one main aspect that joins both IoT and space applications is that a great deal of attacks are human-based, and those are equivalent both for the space applications and the ground. So, as I mentioned, we went to a great deal to, for instance, to secure that the certificate creation has at least a certain number of employees that can proceed on those with the redundancy. Also, the actual access to the facilities, it's important if you're doing secure satellites, it's also important, and the supply chain is also very important, including the manufacturing. I do believe that some of you might be making your own satellites, but for those who aren't, it's important to make sure that the device will communicate only with you, and that's what we did on our side.
So if I understand correctly, also for the audience, you pretty much consider the highest level of threats, right? Like in your threat model, you had the state-sponsored attacks, and
yes.
you really included everything, just to clarify. Let's ask Alexandre where you guys stand in that gauge from that student just doing some bricolage in his garage and wanting to play around with the satellite signals, or all the way to state-sponsored attacks were targeting assets. Where do you guys sit?
Well, it's not that an easy question actually, because like you said, knowing your enemy is important, but you don't always know him. And in our case, well, there is an important point about jamming and interferences, because when you have a ground telecom system, you have several base stations, well, a lot of them, and you can jam one or two or a few of them quite easily. But jamming a whole network is another task. While with space constellation, at least with our space 25 nanosatellite constellation, it's the bad news. It's quite easier to jam, because with one jammer on the ground almost anywhere, you can reach several satellites, and because they are moving, you can reach the whole constellation at a frequent time. The good news is, because they are moving, we can use the Doppler effect and do some Doppler localization, so we can actually quickly check where these jammers are, and we can go on intervention, and sometimes it has to go up at the state level to communicate state to state to localize a jammer on the ground. So to answer fully your question, we have both cases, but usually it has been either not maybe student, but at least some company that want to try the frequencies and try the modulation by itself, and sending too much power in the device, and so this has been an issue. Or we have several state institutional bodies that have used some jammers, but it was not intentional to our system. It was more for jamming the ground in operation. It happened that it had some impact on our system. It has never been a real issue in the sense that it has never put our system down or damaged anything, but still it's something that we monitor a lot.
Yeah. Maybe coming back to Nuno, and we heard several times during the event, I think Enrique from GMB said as soon as they got some software running in the public cloud, they got hacked, they got attacked. Kineis mentioned that they were subjected to an attack in 2011. He's also said that they're subjected to cyber attacks every single day, same as Stefano. Have you guys, what can you share about attacks? Have you been attacked before? Do you have any lessons learned?
No, from actual attacks, no, we don't have records of any particular attacks, but we also have, it isn't that we don't take that into account, but usually we work on private networks. So the security mechanism that we already discussing are on top of some private networks regarding the internet. So to access our cloud-based monitoring system, you need to have a VPN access. That's typically how we deploy. Not all the cases, but even in the ones that are not deployed like that, we have no record of an attack. But as you know, as everything that's on the cloud, it can be subject to an attack. But the most critical part is really getting that we have signed the information from the field about, for instance, the offender's whereabouts. So this kind of information that comes from the devices is signed. So it's a little bit hard to fake.
Yeah, Alexandre, I don't know, is your service already up and running?
So yes, like I said, we have 8 satellites flying, so we have an up and running service. It will be much better with the upcoming constellation. And so in this system, we haven't been actually the target of a strong attack. Well, when it was satellites, when it was at CLS, our mother company, a few years ago, they have been a target, but they were not the only one. Of cyber attack, but more on their data center more generally. But it's most common, I would say. It was not dedicated specifically to this system.
Yeah, you know, also usually there is this famous plot or graph of the different risks and their consequences versus likelihood. And I've talked to some satellite operators when we discussed the risks typically related to state-sponsored attacks, and some of the reactions were, well, if somebody is ready to put this amount of effort to disturb my service, then they would rather buy the company because that would be a cheaper option. Is there any risks that you guys decided to let go, sort of, like just to say this, we think the likelihood is too small, we're not gonna mitigate that? Alexandre?
Yes, I was thinking it through. Yes and no. I mean, but it's more that certain risks you cannot do a lot about it. Like I was mentioning the jamming issues. So we have put what we can in place to localize and intervene in the most efficient and quick way. Still, you cannot prevent people from using your frequency and sending much RF power in the sky. So except if you don't mention what frequency you're using, but then it's complicated to do business. this is something you deal with, but more in not in a preventive way, but in a reactive way.
Thank you, thank you. All right, let's move to implementation and go back to Mark and Nuno. We heard Nuno explaining that they really implement specific measures, talking about secure element, HSM. Maybe one question to you, Damian. What would be the typical security implementations that you have seen in IoT that could be relevant for space and new space operators in particular?
Right. So I assume that you're interested, well, mainly in this direction of the trust chain and really taking care of the keys and the critical parts of the implementation. And this can vary greatly in IoT depending on the specific segment you target. To be concrete, you won't really need very powerful hardware security features for consumer IoT because you would just overshoot the cost target, right? So in this aspect, IoT can vary greatly depending on your application. The threat landscape and the impact and risks associated to certain threats would change. So no hardware security features in the things for certain consumer IoT products, all the way to actually solid security features using a secure element, or well, at least something which allows you to boot securely, update firmware, and store a key or two securely for medical applications and something like this. So this is on the side of the things. And on the cloud, you definitely see the use of HSMs or at least software key vaults for the most critical keys, right? So something that allows you to update your firmware or communicate with your devices. And
would you agree with that, yeah. Mark?
Yes. I think in terms of the hardware, it can be quite costly, and but for system on chips like that support TE and trust zone, so you can use it at a relatively low cost, let's say. But from the implementation point of view, I think what's very important is not to try and implement your own, let's say, crypto or your own security protocols. And there are well-established libraries like Lipton Crypt, for instance, that already contain a lot of what you probably will need. So I'm not sure you will need anything extra if you want to replicate something that is being done for IoT protocols in terms of crypto and communications. But what additionally I would say is that in the IoT domain, we also have a lot of IoT devices that can be accessed through a web, so web browser-based access that enable you to configure devices. And for satellites, I'm not sure if these technologies are being used for satellites too, so whether you can have a web-based access to the satellites, so this perhaps Alexandre can clarify, but we know that using web technologies is quite risky, so you need to do it right. So there are many attacks that exploit web-based kind of communications.
Thank you. I also wanted to touch base on the subject of key provisioning. In IoT, I think some vendors, typically the secure element providers or the ecosystem, allows you to buy kind of the pre-integrated, pre-provisioned secure element or even object that then is ready to be released in the wild, in the field, and quite confident that it will be resilient against even hardware attacks, hands-on attacks on the device itself. Even though there is no hardware attacks on the satellite itself, it is still important to have some secure key provisioning, and maybe I'll be curious to hear Alexandre about that. What would you say, Mark, maybe if I still continue with you, any recommendation or any tips on this aspect of key provisioning? Is it critical? Do you confirm? Do you agree with that?
Yes, absolutely. So that was also the points I raised in my presentation, that you need to ensure that the satellite is keyed in a secure way. And given that we have only a handful of launch facilities in specific certain countries, you want to be sure that nothing is compromised until the time when the satellite is launched. And I believe that since the small nanosatellites, like that weigh 15 kilogram, probably don't have specific crypto units that can be plugged in and brought to the launch facility separately from the satellite, there needs to be a keying done early in advance. And in my opinion, the only way to do keying securely is to use secure hardware elements. So I don't see how else you could do that without using trusted hardware.
Mm-hmm. Alexandre, what is your is that a concern for you, like the key provisioning and also all the potential risks that may be more or less important and more or less likely during the on-ground operations on the satellite itself, transportation, testing, integration, and so on, and the key provisioning that needs to occur at the very last moment? What is your experience on that?
Yeah, yes, definitely. This is a critical process. You have to do it well, of course, but like Mark say, you cannot do it at the very last time when the satellite is on the rocket, and even more, you cannot do it at a very late stage. So we have to do it at the factory of the satellite. So there you have to put in place the whole protocol needed to do it correctly. And after that, you have to be sure that no one can access the satellite in the same way to do this. So we have put some measures in place to ensure that. Fortunately, I would say it's a disadvantage on the whole, but on this it's an advantage. The whole transportation and then launch campaign does not allow a lot of people and to do something on the satellite, and you don't have a lot of windows to do like even energy charging on the satellite. So there is a little moments where we could identify some risk to compromise the keys on the satellite.
Yeah, thank you for your answer. Nuno, how does Geosatis handle this critical aspect of key provisioning? Do you do it yourself?
Yes, I fully agree with Mark on this. So that's exactly the route that we took. In our case, we negotiated a secure communication channel with the HSM manufacturer, and then the devices are serialized there. And then at the final provisioning in the manufacturing side, we also have a secure rack that does all the needed cryptographic exchanges. But this happens already at HSM, at the provisioning, at the manufacturing of the hardware security modules.
Maybe let's hear Mark on this on the risks related to ride sharing. I think it was you that mentioned it during your presentation, that there is the popular trend to have a lot of different satellites from different countries, different manufacturers, different operators being launched on the same site. Is that something that you think should be worth taking into account?
Well, I mean, that opens the opportunity, because if representatives from all these companies are there at the start of a launch, right, then there might be issues. So there is some risk there. But what I highlighted is that essentially you stack many satellites on the launch vehicle, and they might come from different organizations. And if the launch is delayed, for example, and the satellites need to be unpowered, then you can't really maintain eyes on your satellites every time. So there is certain risk associated there. So yeah.
Okay, thank you. Let's talk about the deployment and operation phase. Obviously, there is no maintenance in space. There is no physical attacks. Same for the bracelets. Maybe let's hear Nuno about how do you handle security once the bracelets are actually in the field and worn by the prisoners and so on. What's happening when the bracelet is purchased by the customer, is in operation, in service?
Actually, there's where we have the attack. So even if our bracelet is quite robust, if you go to some measure, please don't forget that usually have a foot attached, but the most common attack is trying to cut the bracelet. It's a little bit hard, but this happens. Of course, we have the device protection. We have alarms whenever the integrity of the device is violated. And that's how we handle it. But maintenance, I think we're talking also in different volumes. We can we have remote upgrade on the field, but we have also the option of recalling the devices if something goes wrong. It doesn't happen so frequently, because also at the fabrication stage, we test 100% of the devices to whole subsystems that go into the device. This being the communications, the sensors. We don't have so many recalls, but we always have that option. While compared to the satellites, it will be a little bit more difficult. Yeah.
Mm-hmm. Let's hear, Mark, about your recommendations on the best practices of security once the satellite is flying. What should operators take care of?
Well, I would say to control the ground station is the most critical. Well, I mean, that's where the control lies on the ground, right? So you wouldn't expect someone to fly near the satellite and take over control from there. And the more complex the ground station is, as we know, the ground stations are distributed, so there needs to be communication, so they're interconnected. If we move them to the cloud, then that introduces a different vector of attacks. And in one of the presentations, I think yesterday, we've heard that the cloud provider of this ground station as a service don't want to manage keys. So in that presentation, it was clearly said that the key management is not done in the cloud by us. It's still with the operator, which essentially means that this management needs to have more protection because it's managed by the operator, right? So, yeah.
Thank you. Let's go back maybe to Alexandre for a second about the management of security while the satellite is in orbit.
Yes, I think Mark has pointed a very good point through the ground station. I was mentioning it at the beginning. It's definitely where strategic information is going through to control the satellite. So. But again, this has been to be thought in the first place, because when you have your network of ground stations around the world, it's a little too late to remember that you haven't secured your command beacon at the opposite side of the globe. So after that, it's really in the operation room and all the I would say classical threat analysis in the operation of IT system. That you have to care about, and so all this in order to secure the communication with the satellite and the control with the satellite.
Thank you. One more question to you guys about audits and pen testing, trying to really test the system. Maybe Nuno at Geosatis, have you done that? I expect so, but can you maybe?
I'm sorry, but I didn't get your.
I was
part of your question, sorry.
I was mentioning all the security audits or the penetration testing that companies do on their systems to try to confirm that they are actually
yes.
mitigating.
This came early in the design of the system, and what we did, as I said.
Yes, I can hear you. Yep.
Okay, so this came early in the design of the system. As I said, it was one of the challenges to find the correct partners to do it, and so we work with specialists to do audits on the code itself, and also to test the penetration of the system. That being, it's more the physical penetration will be, as I said, it's the most critical part, since the architecture of the security system itself has been validated independently.
Were you surprised sometimes by the results, or in a good way or in a bad way?
Both. Both. I think in some tests we performed better than expected. In others, we had some surprises, as we always get in this kinds of analysis. It's always interesting to see, but I think overall the device performed quite well.
Just to give
even
an
some
idea
clients, some clients do perform very, very sophisticated attacks on the devices on the testing period. Just to let you know.
Just to give an idea to the participants of how much testing you do on your system, can you quantify a bit? Is it once a year, or are you testing the bracelet for each generation and then that's it? Can you elaborate a bit?
No, we do. It's for every revision. So we have hardware validation and user acceptance test that we do typically with our own commercial side, and but then we repeat this process with every, for instance, firmware revision. So we have frequent firmware revisions to add more features, to possibly correct bugs, and we do these steps. And typically we try to allocate 1/3 of the development time to testing.
Oh wow, it's quite significant. What about you, Alexandre, at Kineis? Penetration testing, audits, have you done that?
Yeah, well, yes and no. On the future satellite, they've not built yet, so we haven't done that so far. So we have done things on the hardware for the beacons, the terminals, because we are providing small modules to a beacon manufacturer to build devices connected to the system. And on the current satellites, I can't really answer, because they are all legacy satellites. So some of them have been launched like 20 years ago. So I don't exactly know what they've done at that time. So we have done the things before in operation, but yeah. So but we have done. I don't know what has been done in the first place in the satellites.
Thank you. One last question on my side to Mark and Damian. How can you manage the obsolescence and the fact that you may have, as Alexandre just mentioned, satellites orbiting for a number of years and then launching the new generation that is using different set of hardware and software, and we see a bit maybe similar situations in IoT. What would be the best practices or your recommendations to make it as secure as possible? Maybe starting with you, Damian.
Right, that's a good question. So there are certainly different things you can do. One of them that we're also looking at right now is to come up with ways you can harden your system, which is kind of independent of the hardware security foundations, to kind of, well, disperse the risk or allow the system to recover. Sorry, to give a concrete example, we're looking into using threshold cryptography, which can be something very interesting for constellations, especially where you have multiple satellites that know how to talk to each other potentially. And if you know that your satellite will be able to see a few of its colleagues at any time or reasonably often, then you can use threshold cryptography to ensure you protect the most critical keys, or that you can restore security on compromised devices later on. I think that's also in line with what Mark mentioned in his presentation. cryptographic sharing. That's like the base level of this direction of research, but then you have some more interesting schemes. And what makes the link with IoT, and that's what we're looking at, we're trying to make it as low overhead as possible, right? Because communication overhead and sometimes computation at a certain extent can be expensive. So that's one thing you can do.
Thank you, Mark. Do you want to comment on that?
Yeah, so talking about the legacy systems, and I mean the constellation is a dynamic object, right? And so you really need to plan that new satellites will be joining the constellation, and some satellites will be leaving the constellation. But I think what you want to ensure is that you don't sacrifice security in favor of, let's say, interoperability or backwards compatibility. So because in that case, you are likely to end up in a situation that we currently have with the web servers and the TLS versions, SSL 1.2, TLS 1.1, 2.1.3, and so on. So yeah, so I think that's why it's good to have standardized protocols in place, because then if you are using standardized protocols, typically there will be ways to evolve them. And again, this will be evolved through a standards community. So it will be better when you try to do it yourself, if you try to design interoperability or backwards compatibility for proprietary protocols that you develop yourself.
Okay, thank you. We're reaching the hour. It's already past 6 o'clock, so we'll wrap up shortly. Maybe let's go back to Alexandre and Nuno. Alexandre, shortly, can you tease us a bit of what's coming up next with the Kineis? Are you launching soon, or maybe anything you want to share about what's coming up with the company?
Yes, the one where we actually deep into the final design of the satellites and the beginning of the production this year. So by the end of the year, we'll have our flat satellite that we will test extensively, plus the first ground station that we'll begin to deploy. And so, and we will launch in 2023. So till then, there is a lot of work, and we mainly focus on the device side because from a business point of view, at the end of the day, the customer is seeing just the device and the data, but he's not seeing the satellite. So this is really a major point of the business. So there was a lot of work on that point, and we're working on a very small because we have already one very small chip that includes a lot of features to be easy to integrate by third parties to make a device for the system.
Excellent. I did not expect to ask that question, but just came to my mind. I mentioned earlier that for the next edition next year of CYSAT 2022, we would like to also couple it with the hacker competition and potentially using real satellites. If you have any satellites, Alexandre, hanging out at the Kineis facilities that you're not using anymore, old versions, please send them to us for the next year's edition, and we'll ask the ethical hackers to have a go at them and see what they can do with it. I don't know if that sounds like a good idea to you or a terrible idea. You don't have it to.
On the principle, ethical hacking is still an idea I like, but I will talk to my tech team and get back to you.
I didn't expect a clear yes, so no worries, no pressure. Nuno, do you want to have a last word on Geosatis?
Well, I think one thing that's coming up on our side, we're in the final stages of developing not bracelets, but also applications that will running on off-the-shelf cell phones that plug into our system. And we had a great challenge there to ensure that they keep at least an equivalent level of security while accessing the system. And we chose to go on the same route. We are using off-the-shelf devices, but they do have hardware security modules included, and that's the route. It's a little bit more complicated in terms of provisioning, but I think it's the way to go. So this is the latest security challenge that we faced.
Okay, thank you, Nuno. Mark, any concluding remarks on that panel discussion on your side?
Well, I guess we all need to stay safe, whether here on Earth or up there in space.
Yeah, that's a good one. Thanks, thanks a lot. Damian, do you want to add anything?
Perhaps only that I believe that there are similarities between the satellite systems, especially constellations, and what we can do in IoT, and that there will be a high degree of reusability between security solutions for one and another, especially because you have the same tendency to be secure, but also be efficient. So I would be on the lookout.
Excellent.
There as well.
Yeah, well noted. Thank you so much, everyone, for this panel discussion. Thank you, Alexandre. Thank you, Nuno. Thank you, Damian, and thank you, Mark. It was a great pleasure to have you. Thanks a lot again for participating.